Hi, my name is Michael Van Babel. I'm the president of Dynamax. We've been working on Sap Flow Sensors here for 30 years, and we've been improving them considerably since the 1980s. So what I'm going to do is introduce to you the installation of Sap Flow Sensors, the SGDC, which is a brand new sensor, and the ExoSkin Sap Flow sensor. So first I have the original Dynagauge. This is a heat balance sensor. It has heater in the middle, but as you can see, there are various parts to it, and that's called the Dynagauge. And then Dynamax also created the ExoSkin sensor, which is a heater with a skin around it, and exo means the outer in Greek. So this is a new design of stem flow heat balance sensor, also called the SHB method. And then we also have a new, this is a SGDC sensor, a stem gauge with a dual channel design, which keeps very good accuracy, but it keeps down the number of channels so that you may put twice as many of these sensors on a data logger than you can the SGDC or the Dynagauges. So this makes the system less expensive because the data logger is less expensive. You can put more sensors on the data logger, and it also gives you a very flexible sensor, which allows the sensor to attach to a variety of plants and grow with those plants. So on the new SGDC and ExoSkin sensors, the heater comes with a very special design. It's got a new quad layer of integration of Mylar and the heater itself. So it should be able to last about 3 to 4 years with proper maintenance and with good installation practices. So this does add durability. We also have thermosensors on the SGDC and on the ExoSkin that come in direct contact with the regular stems. So this could be a very irregular stem and I would still get good contact with the sap flow heat as it's applied to the sap flow itself. All of the ExoSkin sensors come with a sealed watertight locking connector. It's required that you use a O-ring and grease inside the connector. And then each of the SGDC, the heater power is monitored inside the SAP IP. So we monitor this voltage as it's applied by the SAP IP data logger. The SGEX, the heater is monitored in the cable itself. So this cable does have extra pins to monitor the voltage as it's applied to the sensor. So the system connections to the sensor are through a circular plastic connector. That's a 9-pin connector. It's sealed with a G4 grease, this type of silicone grease, and an O-ring that's inside the connector. That has to be there as you connect the data logger. On the ExoSkin sensors, we use the SAP IP CS1 or the SAP IP CS4 connection, and then for the SGDC sensors we use the SAP IP CS3 cable connectors, and both of those can use the extensions the EXQC25 or EXQC50. So I'd like to go through the installation tools that you'll need to put the Sap Flow sensors into on the plant. I'm going to introduce to you all the tools that you'll need to have in your tool kit so that you can install the sensors properly and get good readings. So first of all, I'd like to start with preparing the plant. You'll probably need to have a plant cutter, a sharp knife. You probably need to use sandpaper to smooth the stem, and to adjust your wiring as you install the insulation you might also need a wire cutter. Also, to measure the plant, you'll probably need a caliper to be able to measure the diameter. And then you would also want to have water and paper towels to be able to clean the stem of the plant. Also, with the sensor, we provide stretch Velcro. That'll be used to apply the sensor to the plant. And we also apply some cork strips that are used to fill any gaps as you put the sensor on the plant. And we'll show you how to do that later. We also provide, we call these donuts, or these are insulation tubes that allow the heat inside the sensor to be very stable. So we also recommend that you have clear tape or vinyl tape. Vinyl tape is a stretchable one, is probably preferable if you use that on the outside of the reflectors that keep the sensor stable. And we also recommend that you use wire ties to be able to install the sensor and the accessories on the plant. As you install the sensor, you'll probably need grease. And you'll also use canola oil to keep the sensor from sticking to the plant. All right, so here's the reflective shield that's provided with the sensor. That'll be cut and adjusted as we install it on the plant. And then we also recommend that you have a voltmeter to check your batteries to make sure that everything's operating correctly before you start your data taking. So first, I've measured the plant, and it's about 10 millimeters. I will use that information to index the stem diameter to a stem area and to be able to index the sap flow to a total set of plants. That would be necessary for the commercial application, and for science application, I would also try to measure the leaf area index or leaf area of the plants. So for installing the sensors, the next step is to be able to clear the stem. And so I've got some areas that I think are going to interfere with the stem installation. So I'll go ahead and trim those out. Then I'll use the knife to clear out any areas where the sap flow sensor would be. So if I see that there's a problem with this part of the stem, I might clear that out with an X-Acto knife or a sharp knife. And this might interfere with the installation of the sensor. And this part here might interfere. So I've cleared that part of this stem out. And then next I would use some sandpaper. And I would clear any dead bark off the stem. I do not want to see any green part of the stem. So the idea is to maintain the living cambium that's underneath. But I do want the sap flow sensor to be able to have good contact. So this part appears to be clear, and I'll be able to clean that off. I'll use the water and a paper towel. Some plants do not need to be sanded. If it was a younger cotton plant, or a hibiscus in the case of this sensor here, or this plant stem here, I may just be able to clean the stem without doing any sanding. So I want to get rid of any interfering debris on the plant. And then next I would put some canola oil on the stem. Okay, this canola oil will keep the sap flow sensor from sticking to the plant. Here's the sap flow sensor I would like to use. This is the SGDC 10. That's the dual channel sensor. You'll note that I'm taking off the two double-sided Velcros. Those are used for putting on the sensor while it's being shipped. What I'd like to do is I can use that. Since I don't have an assistant, I will try to install the sensor on the plant as it's facing you. And I'll tuck inside the heater so that it fits inside the other part of the sap flow sensor. Now you'll note there is a gap there, and I would like to fill that part of the gap with this cork. So I'll actually cut that cork with the scissors to be able to make that part of the heater stick strongly to the stem. So that part of it right there goes in that gap. So in the meantime, I can use the installation double-sided Velcro to hold it into position. And the very next step is I use the stretch Velcro and I'll wrap it around the stem Sap Flow sensor, but I'll also start right here at this Velcro, and I'll stretch it to give a little security to securing the heater to the stem. And then as I wrap around it, I'll stretch it a little bit more, and then I'll be securing the upper thermocouples directly to the stem. So each time I pull on it, I'm stretching it about 20% or so. Not too strong, but just enough to keep the sensor from moving around. Okay, now that I've got the upper part done, I can remove the double-sided Velcro and I can install the bottom part. So each time I'll stretch it a little bit. Then as I cover the sensor, I'll also strap the wiring to the Velcro. And that sensor is on there securely. I cannot move it with my fingers with an easy motion. Okay, let's start with the next step. Before we do that, I want to talk about the Velstretch wrapping. That's this part here, this stretchable Velcro. So the idea is that it's going to grow with the plant. The plant will shrink and swell every day. We want to have a good installation that will accommodate the growth. And this material is made of a breathable material. It's porous nylon and lycra spandex. So it's collecting moisture as it comes away from the plant, and it'll conduct that to water away from the stem. And so that's going to reduce mildew and possibly reduce stem damage. So the next thing that we apply is a Gore-Tex shield over the stem, over the entire sensor. And this will be wrapped around the Sap Flow sensor. And the Gore-Tex itself will take any moisture and allow it to go out as a water vapor, but it will not allow water to go in. In other words, if there's rain or condensation, then it will not penetrate, that liquid will not penetrate this Gore-Tex shield. This is the same thing that we make raincoats out of these days. So I'm going to cut a little bit off the shield. It's made to go around the entire insulating compound, but for the SGDC and the ExoSkin sensor, we only need to go around this bottom part of the sensor. So I will trim it down to right about there. I will make sure that the top is very secure and the bottom does allow water vapor to escape. All right, so it's going to be at approximately this angle here. This one could be trimmed a little bit smaller. That's approximately the idea. Okay, that's double-sided Velcro, just holding it in place, and then I'll secure the top. This part of the installation, I have taped 2 wraps of flexible tape around the top, so I'm securing the Gore-Tex raincoat over the Sap Flow sensor. The bottom, I'm just using one of the double-sided Velcro, so it's allowing any liquid to drain out, But the main thing is that I want the water vapor to exude through this cloth, and the bottom is going to be open. So that's going to extract the water vapor, it's going to reduce condensation buildup inside, and then it'll reduce corrosion or any possible damage to the stem. Okay, so my next step is to prepare the reflectix. These are the radiation shields that go around the Sap Flow sensor. And I'm basically cut these to shape. One of them goes on the very bottom of the Sap Flow sensor. I want to keep any exposed part of the stem from being affected by direct solar radiation. So I'll actually put that down. If this plant was sticking up taller, I would certainly use a longer piece of reflectix to be able to shield that part from the solar radiation. So I'll just go ahead and put that on there with a tie wrap. And then I'll use the wire cutter to trim that out. And then the very next step is I want to be able to install the insulators that keep this part of the stem stable. And it usually covers from the ground all the way up to about 1 sensor height above the Sap Flow sensor. So I'll do that. I don't have room at the bottom, so I'm going to go ahead and put the middle donut, which is the insulating ring, on top. So I'll put that down as far as I can go. Okay. Secondly, then I'll put the next donut on top of that, my foam donuts. Then I'm ready to install the reflectix all over the entire shield. So I've actually cut it. These are always provided with the sensors, and I'll start to install that around the Sap Flow gauge. So this will keep radiation from affecting the readings and upsetting the energy balance. Okay, I'm starting to close up the reflectix, and usually I'll use a wire tie to do that. I have one wire tie on the top. So there's one wire tie. Then I'll use actually 2 wire ties on the bottom side. Much easier. That'll keep it in position. Use the wire cutter. And then I'll use the tape, either the clear tape. I prefer actually white to go around the top. And I want to seal this plant against any water that might be applied from irrigation or rain. That'll go on top of the Sap Flow sensor. All right. Okay, as part of the setup, you also want to take the readings that you have from the stem, from your caliper readings, from any area readings, write those down. You also want to write down the ohms that's displayed on the serial number tag on the Sap Flow sensor. So that's part of the electrical setup that you'll use as you put this information into either agrisensors or into the Flow 32 Sap Flow system. Next, I've put in the reflective shield. That's 2 layers of reflective sort of plastic bubbles that's required to reduce the radiant heat, and that's also reducing the NTG, the natural thermal gradient. And of course it provides a conductive barrier. If you do get a lot of thermal gradients, for example if this is a potted plant, I would cover this with foil to make sure that the heat from the sun does not get into the bottom and upset the energy balance by changing the temperature of the water. So here's the complete installation. All these parts of the installation would take about 15 to 20 minutes, depending on if you're going to need to remove some bark or how much cleaning and preparation is required. It also helps if you have an assistant to hold the parts and to keep the tools flowing into the working area. So I also want to bring up that we do need to do an electrical system setup, which is next. First thing we mentioned was to insulate the connector, which has grease inside. It has an O-ring inside. Second is to check the voltage on your batteries. These should be marine deep cycle batteries, and they should have a full charge. If they're 1 to 2 years old, these batteries should last that long. Now, voltmeters needed, but a battery tester is actually recommended. So then you would set the voltage to the heater using the Sap IP or the Flow 32 Sap Flow system. And so we will show you some minimum specs at the end of this video to show you what are the recommended voltages that you should use. So we have one set of voltages for the SGDC. We have another set of voltages for the exoskin sensors. And you should always start with the minimum voltage to start out and get your first readings, and then increase it as the plant grows or when it gets hotter. So thank you very much. Appreciate your time and hope you got a lot out of this video.